chapter for some of you, or it's going to be the most difficult. And it's weird who it's the easiest for. Usually it's the easiest for those who feel like they're dumb. And it's usually the hardest for those who feel like, oh, you need to take the test too.
Me?
Yeah,
Yep.
didn't you?
Yes, I do. But
Okay, so let me explain why. So those of you who feel like you really struggle with math, you're going to like this. And those of you who actually do well at math and kind of get it pretty easy, you're going to hate this. And the reason is because there's not a specific pattern. So people who do well at math, I show you the process or pattern, and then you just repeat it, and it's easy, right? That's how it is. It's easy. So people like Aspen, heck, she sees it once, she's got it. She's never going to have to worry about it. She just can repeat the process over and over again. It's not that hard. Once you've seen it, you can do it over and over again, okay? That's a lot of people who are good at math. That's the way they think, okay? But this is going to be more, you just have to think through it. Every problem is different. It won't have the same process. Every problem will not have the same process. There are some principles that apply, but it's not easy. Have you started? Okay. All right. So the first principle is called sample space. So write this in your notes. Sample space is a super easy thing to understand. It's all possibilities. Write that down. The sample space is all possible outcomes. All possibilities are all possible outcomes. So think about this quarter. If I flip the quarter, what's the sample space?
each side.
Each side. So the sample space is 2. 2 is the sample space for a quarter because it has 2 sides, heads or what? Tails. That's all the possibilities. There's no other possibility. Everybody got it? What's the sample space for a dice?
6.
What's the sample space for the sum of 2 dice?
36.
So you're talking about.
This is tricky. This is where it gets tricky.
So it
Okay.
could be 1, 2.
There's actually the sample space of the sum of 2 dice is only 10. When I roll these dice, what are the possibilities?
So you can only get 10 outcomes.
No. What are the possibilities? I roll the dice. What can I roll? Sum on the dice.
2.
2 is a possibility.
6.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's only what? There's actually 11. 2 through 12, right? So there's 11 possibilities is all. So really, the sample space of what there are is 11, which doesn't make any sense whatsoever, but that's what it is. However, what you said, Alex, is right. In that how many different rolls or sums of rolls are possible on 2 dice? What'd you say?
36.
How come he said 36? 6 possibilities times 6 possibilities. That mathematically, see how Alex's mathematical mind, that makes sense. But when I said, well, there's 11, you're like, well, how in the heck did he get 11? That makes no sense. And it doesn't. Because the sum of the dice is either 12, 6 and 6, or 2 is the worst, right? Everything in between you could roll. So really there's only 11. But that's the sample space of what could happen. But how many ways that can happen is the 36. So there's the number of ways versus the sample space. They're different. Okay? The sample space is the outcomes, number of outcomes. Drawing a card. 52. That's important. And by the way, if you don't play cards a lot, because it's weird, because some people play cards all the time, have a good sense of what a deck of cards is and looks like, and some people don't. So let's make sure, if you're not, write this down, okay? 52 cards in a deck. Made up of how many suits? You need to understand the language of cards a little bit as we do this part. There's how many suits? 4. What are they? Hearts, spades, clubs, and diamonds. Hearts, spades, clubs, and diamonds. Now, how many cards are in each suit? 13. Okay? So how many ranks are there? That's the other word that we use in cards. What is the rank? The rank is the value on it. So it's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. By the way, that's why there's how many? 13 ranks. There's 13 ranks, 4 suits. 4 times 13, by the way, make 52. That's how we get the 52. Everybody understand cards a little bit now. You don't have to understand everything. Okay, that's the sample space of cards. So if I ask you to draw a card, the sample space is what? 52. Sample space is how many possibilities there are. Everybody got it? Super easy on sample space. If a spinner has 10 spots on the spinner, you ever played Life? The game of Life? Has 10 spots on the spinner, right? You spin the thing. What's the different possibilities then? What's the sample space? 10. There's 0 through 9. You see what I mean? There's 10 sample spaces.
Wait, but there's, so if there was a 10 on it, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10?
Then there would be 10. But if there was a 0 and a 10 on it, there's 11. Just like when they're all rolling the dice, right? A 2 to 12 is actually 11. Is that true? I don't know. Think about that. 0 to 9 is the same as 1 to 10.
Yeah.
See the 0 being counted? So you're counting it twice. All right. So that's sample space. Any questions on sample space? Okay. Now, next thing we want to talk about. Probability of an event occurring. This is the most important thing on this lesson. The probability of an event A. This is the probability that A occurs. How do we measure probability? How do we measure probability? So let me just ask you this simple question and it'll explain probability. What's the probability that I flip this coin and it lands on a head? How did you get your... It's 1 divided by 2. There's only one possibility of being ahead, and there's total possibilities of how many? 2, either heads or tails, right? So it's 1 out of 2. I got a 50-50 shot.
Tails never fails.
Tails never fails. All right, so it wasn't heads. But the probability of being a heads or a tails is seriously 50-50. That's all there is to it. There's no big thing, and the reason it's 50-50 is it's 1 out of 2. Okay, rolling a dice. I'm going to roll the dice. Okay, Simeon, what's the probability of me rolling a 2 on the dice? 16. 20. Just do it simple. Don't give me the whole percentage. Just what is it? One side is 2 out of what?
6.
6. That's it. Don't make it complicated. It's 1 out of what?
6.
Now, tell me what the probability of an event A occurring is.
1 out of the amount?
It's the outcomes of A, those that are true, things for A, divided by total outcomes. Okay? The outcomes of A divided by the total outcomes. Okay? Is swim leaving?
Yeah.
Okay. So that's going to be the key on this. And we may not do an assignment today, by the way, Alex.
Okay.
We're probably just going to play around. So, sorry. Some of you may be upset about that because you're like, dude, I want an assignment so bad. But
No.
no. Okay. Good.
Yeah,
Okay.
please stop.
So let's see what else here. Sample space. Okay. So, or by the way, you could write total outcomes or the what? Sample space. That's how many possible outcomes there are. So you can write it but divided by the total outcomes. Okay? Now, there's 2 different things. And this is important. Again, things you need to write in your notes so you know the difference between theoretical probability. I don't know how to spell probability. I don't know. I'm making up how to spell probability. Anyway, there's theoretical probability and there's actual probability. Oh wait, I don't want to call it actual. I gotta have the same word that the book uses.
Experimental?
Experimental, there you go, that's the word. I call it actual, but yeah, it's experimental. And I'm going to tell you a story about this. So, everybody started learning that one of the worst games to play in Vegas, there's different, like the chances of winning in blackjack, for example, in Vegas. If you know how to pay attention to what cards were dealt, they call it card counting a little bit. What's the chances of you winning in cards in Vegas? They could actually end up being in your favor, which is weird because who usually makes money? The casino. The casino makes the money. You bet it, you lose it. that's how gambling works. You bet it, you lose it eventually, right? You may win one time, but over time, you're probably going to lose. One of the few ones that you don't is blackjack. Well, people were playing blackjack and they weren't playing roulette. Do you guys know what roulette is? It's this big spinning wheel. They throw a marble around the wheel. It spins and it lands on a color. Half of the, well, not quite half. Almost half of them are, I think there's like 80 spots. And 40 of them are red and 40 of them are black. So you can either bet on red or black. And then 2 of them are green. Now, why are the 2 green there for? Because if you bet on red, or if you bet on black, you would win half the time. Would the casino ever make any money? No, but if you bet on red or black, either one, and it lands on green, the casino wins all the money, both the ones who are bet on red and black. That gives them an advantage. You see what I mean? And the casinos always have an advantage. That's the whole point of them owning the casino. So if you want to gamble, by the way, this is the key, own the casino. Then it's not a gamble. Everything else is a gamble, so you're going to lose your money, right? Well, casinos found that nobody was betting on roulette. They were like, and dude, we make money on roulette. They wanted people to bet on roulette. And they decided to post a board of what the last numbers were. So, for example, it would be black, 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 black. And everybody would see all these blacks, and then guess what everybody would want to go bet? Well, some would say, well, heck, it's always going to hit black, and they'd want to bet the black. Other people are going to say, well, it's hit black this many times in a row. There's half of them are red. It's got to hit what? Red. And they'd all bet red. Well, but more people started betting, and that's all they wanted. Because as long as they're betting, they win eventually. Doesn't matter what they're betting on. Because does the wheel know what it just did? Does the wheel know that it's hit 6 blacks in a row? It has no idea. Every spin is about 48%, right, that it will hit red or black. The other 4% is when it hits green. You with me? And so that's why the casino doesn't care. So it started posting this, and all of a sudden people started playing roulette more, and the casino started making more money. Just because they got people to bet. Because they saw, oh, it hit 6 straight blacks or whatever. I better bet red. Or, because it's got to hit red eventually. Well, that isn't true. Because experimental probability isn't the same as theoretical. Theoretically, if you have 100 times that it's black in a row, you would think, well, we got to catch up. It's got to hit 100 reds. That makes sense. But the wheel doesn't know that. It still thinks it's every spin is itself. So that's the difference between theoretical and experimental. We'll show you that right here in a second. Take out a piece of paper. You're going to roll this dice while I'm talking. Can you do 2 things at once?
Yeah.
Okay. I want you to write down 1, 2, 3, 4, 5, 6. Just tell me what you roll every time. And I want you to roll that 50 times. Well, 60 times. Okay? So I want you to roll this 60 times. Can you count to 60?
Yeah.
Okay. Every time you roll this, mark it. And then you count your tally marks. Do you know how to do tally marks? Everybody know how to do tally marks? 1, 2, 3, 4, 5 across it, right? You see what I'm saying?
Yeah.
Okay, 60 times, roll that dice. Mark what you get. Okay, so theoretical is what mathematically should occur, and experimental is that which actually occurred. Write that in your notes. Theoretical is what mathematically should occur, and experimental is that which actually occurred, based on actual data. Okay? What I'm having, it's Courtney, right?
Yeah.
What I'm having Courtney do is what?
Roll dice.
Theoretical or experimental?
Experimental.
It's experimental. We can already do the theoretical while she's rolling. How many times should she's rolling it 60 times. How many times should she roll a 1? How many times should she roll a 6? Theoretically, see the difference? Theoretically, she should have 6 of each. Or sorry, 10 of each of the 6 values. You see what I mean? 10 of each is she gonna get that?
No.
I would guarantee you she won't. But that's what the difference is between what? Theoretical versus what? Experimental. Okay. So that's important, is knowing the difference between those two things. All right. Open your books to 280, and we'll go through a few of these. And you're going to learn a new principle also, which Alex kind of applied to. All right? Okay. Example 1 on page 280. It says you flip a coin, which I have, and roll a 6-sided dice. How many possible outcomes are there in the sample space? How many outcomes are there in the sample space? How many possibilities?
What? Repeat that question.
I'm going to roll a dice, and I'm going to flip a coin. How many different possibilities are there, or how many different outcomes? What's in the sample space?
12. 8.
How come there's 12?
Because there's 6 possible on that and 2 on that.
List all 12.
Head.
One head.
Tails, 1 through 6.
Notice how you list them. This is how I would list it.
You got to be like 1 head.
Yeah,
1
two.
tails, 2 heads.
For us.
Literally right here.
It
For a while.
Look at us go.
Me neither. I mean, how do they do that faster?
And there's how many?
12.
12. That wasn't hard to do. How did you really get 12 though? Did you think this way?
No.
Kind of sort of thought that way, but what did you really do?
I'm 65 there.
Ah, that is the key, and that is called the fundamental principle of counting. Write that in your notes. The fundamental principle of counting is to multiply the possibilities. Most kids don't. Now you guys are honors kids, so you think through things a little better than most kids. You see what I mean? But if I was to ask this to my B class that is in 3rd hour, and I said, look, we got a dice with 6 sides on it, and I got a coin with 2 sides on it, what are all the outcomes of rolling a dice and flipping a coin? Guess what they're going to tell me?
8.
They're going to tell me 8. Why are they telling me 8? Well, there's 6 possibilities on this plus 2 on this. That's 8. Are they right? No, they're not right, because you got to multiply the possibilities. It's not 6 plus 2, it's 6 what? Times 2. And it makes sense when you write it out. There's 6 ways that you can have a heads and any one of the 6 numbers. There's 6 ways you can get a tails and any one of the 6 numbers. You see what I mean? So it makes sense that there's 12, but the kids in my other class wouldn't think that way at all. They'd say there's 2 on this and 6 on this. It's got to be 8. But it's not 8, it's 12. Yes? Yeah, the fundamental principle of counting is simply that you multiply the possibility. Possibility. Sorry, multiply the possibility.
You have 10 fingers, right?
Uh-huh.
Wouldn't the sample space be 11 because you've got 0 fingers?
Well, could you have 0 fingers? That's the question.
Yeah.
Oh, okay, I don't know. Okay, let's look at monitoring progress, still page 280, and let's just kind of decide if you can think through it. Don't say it out loud, just see if you can think through it. You flip 2 coins. What's the sample space? Don't say it out loud. Just think it. You flip 2 coins. What's the sample space? Somebody say it now. 4. Okay. I got a question. You flip the same coin twice. What's the sample space?
2.
It's 4.
Still 4. So whether I take the same coin and flip it twice,
Wait, but
how many outcomes are possible?
Still 4. It's just like having 2.
Because I could hit heads, or what?
Tails.
Tails, or tails, or tails, what? Heads. There's still what? 4 possibilities. If I flipped 2 at the same time, and they landed, what would they land on? Either heads, tails, heads, tails, or tails, heads. You see what I'm saying? So it doesn't matter whether you take the same one and flip it twice, or you take 2 of them and flip them at the same time. It's the same. The possible outcomes is still 2 times what? 2, either way, because the sample space was the same. Everybody understand that? Okay. Because the probability was the same, I should say. All right, number 2. You flip 2 coins and roll a 6-sided dice. Don't say it out loud, just think. What's the sample space? 2 coins, you're going to flip, or the same coin twice, either way. And you're going to roll a 6-sided dice. What's your sample space?
24.
24. How'd you get it?
6 times 4.
2 times 2 times 6, right? 2 times 2 is 4. 4 times 6 is 24. Everybody got it? Okay, it's pretty simple. Go to example 2. Student is taking a quiz and randomly guesses the answer. Oh, we got to do this because it's fun.
Because it's fun.
Okay, so we're going to do this too. Let me see if I got some things. I think I do. Let me peek. But I feel the spirit. I know I have them here somewhere, but I don't know where. Wait, let's see what's this. Oh, that is not good. I feel the spirit. Ooh, that's not good because I know those are golf balls. And that I think is tees. That's not good. Ah! Dang it! I know I have some. Where'd I put them? Oh, here's some. Maybe. That's only the one. Oh no, I got a bunch. Sweet. Oh dude, these are ugly too. Nobody will ever use these. Okay. You ever seen these things before? Pass some of those out. Pass some of these out. Pass these out. We're gonna take a quiz. It's gonna be worth 100 points. Or 10 points on your test. You get to choose. This is worth 100 points or 10 points on your test.
10 points on it.
10 points on it.
However you want. 100 points on your assignments or 10 points on your test scores.
Did anybody not get one?
You guys ready? Are you ready?
Yes.
Wait, I don't even know which direction the paper
It don't matter.
is.
Be on the purple side.
Okay.
Okay? And look at numbers 1 through whatever. To get this points, all you gotta do is you have to match me exactly. Okay? You have to match me exactly on whatever I put for the first 5.
No one's gonna get this.
You have to take the test. And the test is no questions. You just have to match me whatever I put on the first 5. Now, think about this. How many different ways could you mark this?
25.
Well, what do we got? How many possibilities on each question?
5.
5. And how many questions?
5.
So there's only how many ways?
25.
Shouldn't somebody get it?
Yeah. Theoretically.
If we all picked a different way to the test.
There's 11 and 25% chance one of us gets it.
Guys,
It's true.
If I let you talk, would you have a pretty good chance of somebody getting it in the class?
There you go.
Maybe. What are you just gonna not say anything?
I don't want you to say anything. I just want you to do it. We're going to do 2 experiments here. Okay? So I want you to answer the first 5 questions. Don't talk. Don't look off anybody. You just do your own. Okay? You mark your 5. I'm going to get a random generator so that I don't bias myself. Okay? And I'm going to mark mine over here. He already had his mark. Everybody ready?
Yeah.
How many of you have B for answer 1? Raise your hand if you have B for answer one. One person has B. How many would I expect to have B, by the way?
Like two.
How many are in the class?
11.
There's 11 or 12 of you in the class? So I would expect 2 or 3 of you to have B, but only one person had B. Is that true? Only one of you has B. So everybody's out but one person. Courtney's got the opportunity. She only has to match the next 4. This is gonna end well. Okay, so. Okay, Courtney, what did you have for number 2?
D?
I have B also.
Wait, what did you say?
B is in baby.
No, I got D as in dog.
No, I didn't.
D as in dog.
Nope, you're wrong.
Oh, we all
Yeah.
lost, guys.
Everybody lost already. Okay.
Good job, Courtney, way to represent.
Okay, now this one is only worth 10 extra credit points. This is only worth 10 extra credit points on the assignments, because I think you could do this. I've had it done before, but not very often, by the way. So I want you to answer questions 6 through 10, but wait, don't do it right now. You're gonna answer questions 6 through 10, but you can talk amongst yourselves. And you're gonna try and match me.
I say